Hello everyone, welcome back to the channel. So today we'll be discussing an important topic which is merge sort for linked list. Here the objective is to sort the linked list in ascending order. So we are given the pointer or reference to the head of the linked list and our task is to sort the given linked list using merge sort. And we have to note that if length of the linked list is odd, then extra node should go in the first list while splitting. So basically, in short, what merge sort says, if I have a list, say taking this example 1, 3, 5, 2, 4 and 1. Then first I will take the middle element, the leftmost element and the element just next to the mid of the list. So the list is divided by this element. So we have two lists as 3, 5, 2 and 4, 1. These are the two lists which are formed. Again, finding the middle element and splitting the list into two, we have 3, 5 in one list, 2 in other list. Similarly, for this we can see that we have 4 in one list, 1 in other list. So first we compare 3 and 5 and then we see that 3 is less than 5, so 3 is placed first. Now this is sorted. Next we have this 3 and 5, so we merge this list and now compare 3, 5 with 2. So comparing these elements, we have 3, 2, here this will be moved to here, so 2, 3 and 5. And then 4, 1. Now comparing this list with this element, we have 2, 3, 4, 5 and here 1. Now lastly, making the comparison, we have 1, 2, 3, 4 and 5. So this is in short what we are doing with the merge sort to sort this list. We will see this in detail further. So now the input is given as 3, 5, 2, 4, 1 and the sorted list will give us output as 1, 2, 3, 4, 5. Taking another example, it has 9, 15 and 0, so the output would be 0, 9, 15. Now let's take other example to understand it in more detail and more better. So let's take 5, 9, 2, and 0. We take these 4 elements. Now our output should be the sorted order of this which would be 0, 2, 5, and 9. So this is our output for this given list. And this 0 here will be pointing to the null pointer, and 9 will also be pointing to the null pointer. Now let's understand our code, and we can try run the same. So I'm removing output for now. Firstly, we are performing merge sort. So merge sort is performed by first comparing head and head next to null. If head or head next is null, we simply return head. This is the base case. Then we have the middle element by passing it to the midpoint function, and then after getting the middle element we assign A as head and B as the mid next. So A would be creating one list and B would be creating another list starting from the mid next, and then we assign mid next as null. So after this we perform the operation of merge sort recursively. So first we sort the list which is on the left hand side, which is A, and then sort the list which is on the right hand side, which is B. After sorting both the lists, we merge both lists here, and hence we return the output. Now let's check what the midpoint function says. So moving to the midpoint function, the base case is written here as well as it is. Now the recursive case is given here. We assign fast and slow pointer to head. So let's assign the fast pointer and the slow pointer. After assigning fast and slow pointer to head, what our next step is to check while fast is not equal to null and fast next is not equal to null, we will move fast to fast next. So here fast is not equal to null, fast next is not equal to null. So we move fast to fast next. After this we check if fast next is null, then we would break this loop. So fast next is not null. We move to the other condition, which is fast next and slow is slow next. So basically we are moving fast by 2 units if the next is not null of it, and slow pointer by 1 unit. So this will be a slow pointer, that will be a fast pointer. Similarly, moving fast to fast next. So this would be our fast next, and if fast next is equal to null, we would break. So fast next is null, we would break, and we would return slow here. So slow here is 9. We get the 9 as the middle element by returning the slow. So we have mid, which was defined in our code here at this point. So we have this mid as 9. Now what we need to do next, we have head as 5 and mid next as 2. So basically what we are doing is we will be separating this list accordingly. We will have one list as 5 and 9. Next list as 2, 0. Now we have null here, but here we are not pointing 9 to anything, and we need null here as well to end the list. So we define mid next as null. So we get this 2 list. Now what our objective is to merge sort the 2 list. So we perform the merge sort operation recursively on these 2 lists. So first of all, we would have 5, 9 and null. So we define the mid pointer here. Mid pointer is according to fast and slow pointer. So we have 5, 9 and then null. So we have our mid pointer as we have fast here and slow here. We move the fast pointer to the next one. And we check that the fast next is null. So we return slow. Slow here is 5. So this list is further divided to 5 and 9. 9 is already pointing to null. And we have this mid next as null. So this will also be pointing to null. So this is further divided into 2 lists. Similarly, we have 2 pointing to null and 0 pointing to null. Now let's see how we are merging this list. So for the merge operation, we see that if A is null, we simply return B, and if B is null, we simply return A. So we take a head pointer. If data of A is less than data of B, so we get C equal to A, and C next would be merge of A next B. Else, if data of A is greater than or equal to data of B, then we are taking C equal to B, and C next will be merge A comma B next, and we will be returning C. So here we can see that data of A, in this case our A would be 2 and B would be 0 for the left case. So data of A is greater than data of B. So we have C equal to B. So our C would be 0, this list, and C next would be merging A comma B next. So we have A here and our B next, which is null, would be merged with it. along with A. So B next is null. So this is null. We would return A. So returning A forms this list. Now after this we would similarly apply the operation for 5 and 9, and it would hence return 0, 2, 5, 9 as a list after merging operations using recursive calls. So once the recursive call is done, it will return C, and C would be our final list, which is here 0, 2, 5 and 9, and hence our list gets sorted with the help of merge sort. Now let's look at the code after compiling and testing it. So our code works fine now. Let's submit and check. So it passes all the test cases, hence the code is working fine. Hope you guys understand this video and you will be able to apply merge sort for linked list now. Thanks for watching.